Okay, so let's implement the star class next as a subclass of the SkyObject. So let's go ahead and do the usual. Create a new class in the entities folder named star. And it's going to be public, even though it doesn't technically need to be. And it's going to be a subclass of SkyObject. There we go. And we need to implement this abstract class properly, so I'm going to use IntelliSense for that. There we go. And let's see. For the cloud, in the cloud class, we implemented the speed property, the getter of the speed property, like this. We simply multiplied the speed of the current speed of the T-Rex by 0.5. Yeah, in the original game, the stars actually move a little bit slower than the clouds. Actually, I think they move a lot slower than the clouds. So yeah, let's maybe go with 0.2 or something. Let's go ahead here. First of all, we need a reference to the T-Rex, which, yeah, there's a protected read-only field in the base class. We can use that. Let's say speed multiplied by 0.2. And we also need to create a constructor here. And I'd like to put that down here. Yeah, looks good. Now, what else? Let's have another quick look at the cloud class. There's not much going on there. Maybe let's look at the texture. And here are the 3 sprites that we need to render. That's actually an animation, if I'm not mistaken, but I'm pretty sure it is. So let's see. Well, it's kind of hard. It's kind of hard to make out where the frames start. This looks okay. Let me just move this down. Or maybe, I'm not sure. No, that doesn't seem right. It's really hard to tell. But I guess width 9 and height also 9, that kind of makes sense. Let's see. Yeah, that seems about right. Yep. Yeah, that seems right. Okay, so that'll be 644 for the x coordinate and 2 for the y coordinate. So let's put a comment here: x 644, y 2, and width and height are both 9. Let's put those values into constants. Let's say private constant integer texture quartz x. Well, let's say initial frame texture quartz x 644. Duplicate this, rename it quartz y, set it to 2, and then another pair of constants, which should be the sprite width, which is 9, And the height will also be 9. I guess we could just use one constant for that and just say size or something, but yeah, let's just go this way. Now, we need to create an instance of sprite animation here. Let's see. So first of all, we need a field. Private sprite animation, which is in our trxrunner.graphics namespace. So we'll add a using directive here. I just had IntelliSense take care of that. Now, let's see. Sprite animation, let's call it animation. There we go. And then we need to initialize that in the constructor, for example. And in order to generate a sprite animation, to create an instance of sprite animation, we need sprites. And I guess we could implement some sort of helper method that can be used if all of the sprites are of the same size. What I'm thinking here is that maybe we could go into the sprite animation class. I mean, we don't have to do this, but it would be kind of neat to have that. So yeah, maybe let's go here into the sprite animation class all the way down, and I'm going to add a public static sprite animation. Call it create simple animation. And then I'm going to give it a couple of parameters. First of all, we need a texture. I'm just going to call it texture. And then I'm going to say int width, int height. And then a point, an argument of type point, and I will name it offset. And then another argument named, let's say, frame count. Okay, so this is going to be just a helper method, a static helper method that creates a very simple animation for us by so basically we just specify what texture to use, what width and height the sprites should be, and the offset between each frame or each sprite of the animation in the texture. So in our case here of the star, the offset would be x0 and y9, because the offset between each frame in the animation is 9 pixels in the vertical direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would give us the next sprite. Okay, and I think I forgot something. We actually also need to specify the length or the duration of each frame. Let's say frame length, because length is shorter than duration. And also we need to define, and I think I'll do that here as the second parameter, another argument of type point, and I'm going to call that start pos, which is the start position, the start coordinates within the texture that indicates where the first frame can be found within the texture. So first of all, I guess it makes sense to have some sort of guard here that checks if null was passed. for the texture because it doesn't make sense. Let's say if texture equals null, throw new argument null exception. And here in the constructor, we can pass the name of the parameter that caused the exception. And a simple way to pass the name of the parameter here is to use the name of operator and pass the argument like this. So now if someone was to call this method and pass null as the texture, an exception would be thrown, which makes sense because we can't work with null as a texture. Now, let's create an instance of sprite animation. Call it anim. And now let's create a loop, a for loop. And we're going to iterate over the number of frames in this animation. Like this. And now for each iteration here, we're going to add a new sprite to the animation. We can do that by simply calling the add frame method that we defined. And here we need to pass a sprite. Let's actually create the sprite first here. Pass the texture. Now we need to calculate the X position. And simply for the first frame, that would be just the start position. So start pos X. And now to calculate the correct offset, we need to use the Y variable and multiply it by the offset, the X offset, and do the same thing for the Y position. Like this. And the width and the height, of course, are always the same. And yeah, that's our sprite. And we can now pass that to the add frame method here. And now we need to calculate the timestamp of each frame, of each frame of the animation. And we can simply achieve that by using the frame length parameter, frame length, and multiply that by I. So that would mean for the first frame of the animation, that would be, let's say we passed 0.5 here, 0.5 multiplied by 0, which is 0. And then the second frame, it would be I would be 1. And then we would have 0.5 multiplied by 1, which would give us 0.5. So yeah, that would be correct. But remember, we need to make sure that we add a dummy frame at the very end. And so let's do that. And we can simply achieve that by, checking first if I is equal to frame count -1, which would be the index of the last frame. And if that is the case, then we want to add another frame to the animation with an identical sprite. So it will be the same sprite here, the same instance. And the timestamp will simply be frame length multiplied by I plus 1. And we need to put this in parentheses. Whoops. There. So this would give us another frame in the animation that is that uses the same sprite as the previous one, just to sort of stretch the last frame. Otherwise, it would only last a split second, and we wouldn't actually be able to see it. Okay. So yeah, that looks good. Now let's actually return this animation here. And now we can use this helper method in our star class to actually create the animation. And it's going to be very simple. We're simply going to say animation equals sprite animation, create simple animation. We need a reference to the texture. So let's add a new argument to the constructor of type texture, 2D. Let's name it sprite sheet. And now we can pass that here. And the start position is yeah, for the start position, we need to pass these coordinates that we defined as constants. So new point. There. And let's actually format that a little more nicely, like this. Now the width would be the sprite width, and the sprite height also needs to be passed. Now the offset is 0 in x direction, and the sprite height in the y direction. And let me format that again here. And what else? The number of frames would be 3. And the length of the frames, well, that really depends. Maybe let's go with 0.4. I think it's a rather slow animation, isn't it? Let me define that as a constant. Quick actions, introduce constant. There. Let's say animation frame length. And then we can adjust that later on. And in the draw method, we need to now actually render that animation to the screen using its draw method. Pass the sprite batch and the position. Oh, yeah, right. We need a position. So let's. Oh, no. We already have a position because we inherit it from the SkyObject class. So we can pass it here. There we go. What else? I think that's it for now. We will need to do some more stuff here later on when we introduce the day-night cycle. But for now, this seems okay. Let me go into the Sky Manager, or maybe let's take another look here. Is this already done? I think it is for now. I can remove this, obviously. Yeah, I think that's okay. So let's go into the Sky Manager class and let's implement the behavior now, the logic for actually spawning stars, similar to how the clouds are spawned, but the values need to be a little different, I guess. Let's see. First of all, we also need to define the minimum and maximum Y position. Oops. And I guess the stars can actually spawn a little bit higher than the clouds. So let's say maybe 10. And the maximum position will be, let's say, 60. And let's do the same for the distance. And I guess they can be a little bit closer together than the clouds. Guess that would be fine. So let's maybe say 120. And for the max distance, maybe let's also go with 400. Maybe a little less, maybe 380. I don't know. Now, what else? We got an instance of random here in this random field. Oh yeah, let's create a new field here. Private integer, target star distance, similar to what we did for the clouds. Maybe we could. I mean, this is going to be very similar to the clouds. So maybe we can sort of generalize that or reuse this here. No, we're just going to keep it simple here. What I want to do here is I want to move the logic for handling the clouds into its own method. And first of all here, the despawning would be exactly the same for the stars as well. So I'm going to actually remove this here. I'm going to comment this out. And then I will say for each SkyObject, let's say, yeah, SkyObject, in entity manager, get entities of type, SkyObject. And then where, same thing as we did with the clouds. And then we simply call the remove entity method like this. So instead of using the concrete type cloud, we're just going to use this SkyObject type. So that way the stars would also be covered and will also be taken care of. And we'll have to see if we have to modify this a little bit as soon as we add the moon as well. But for now, this will be okay. So let's remove this here. And let's move this part into its own method. So maybe let's say, let's cut this. Or actually, let me just create a method here, private. It doesn't have to return anything. Private void, let's say, handle cloud spawning. Something like that. And then I will just move this logic into this new method. And then I will call the handle cloud spawning method up here. Okay. And now I'm going to create a new method called handle star spawning. And it will be very similar to this method here. So first of all, I'm going to get all of the stars that are currently on the screen using the entity manager, like this. And then it's going to be the same thing. Let's actually just copy this. Which kind of leads me to think that we can generalize this. I mean, I guess we could. But yeah, let's just keep it simple for now here. Here we need to use the we need to use the target star distance, of course. And then we're going to generate a new target star distance using the random instance. And here we pass the star min distance as well as the star max distance +1 because it's not inclusive. And then we generate a new y position. Min pos y, star max pos y +1. And then we create an instance of star. pass the sprite sheet, pass the T-Rex, and the position, which you can actually copy from here, because it would be the same. Whoops. There. And then we need to add this new star to the entity manager. Okay. Yeah, and like I said, this is very similar, so we might even want to, we could refactor this into a new method and then simply specify specify the variable parts. But yeah, I mean, I guess it's okay. It's not that big of a deal. I mean, the variable parts would be the type. We could do that using a type parameter. We could have a generic method. But also this instantiation here would also be different. And we would have to use different fields. Yeah, I guess it's fine. It's not that big a deal. Some slight redundance, but not too much, so let's not worry about that. Now let's call the handle star spawning method up here in the update method. And yeah, I think that'll be it. Now obviously the stars should only be rendered at nighttime, but for testing purposes, let's keep it like this now, and let's look at how it actually looks in the game. Did I forget something? I don't think so. Let's see. Okay, there's a star. Maybe it's moving a little too slow. There's another one. And I think we need to actually make sure that the stars are always rendered behind the clouds. Actually, let me go ahead and say let's go into the SkyObject class here. Yeah, and we implemented the draw order as a order property. And that's fine, I guess. Let's go into the Sky Manager, and then I will go up here and create a couple new constants. Let's say cloud draw order, and that'll be something negative to make sure that it's always in the background. So let's say -1, and same thing for stars. It should be -2, so that they are always drawn behind the clouds. And then here, after instantiating the cloud, let us set the draw order to that constant value, like this. And the same thing for the star. Oh, and we actually did forget something. I just remembered. Let's move into the star class here. And what we forgot was to actually update the animation and to also make it loop. So first of all, here in the constructor, let's go down here and say animation should loop equals true. So we're setting the should loop property to true to indicate that, yeah, the animation should not stop once it has reached its end, but it should actually loop over and over again. And now we need to also update this animation. Let me take a brief look at the SkyObject class here. Yeah. So the update method is virtual. That allows us to override it. Let us do that. Whoops. There. And first thing we do is we call the base implementation of the update method. That is fine. And after that, we say animation update and pass the game time. But we only want to update the animation if the T-Rex is alive. Or do we? I mean, maybe the stars should keep sparkling even if the T-Rex is dead. But it would be kind of inconsistent with the rest of the game, I guess. So yeah, let's keep it like this. I mean, we can take a look at the original game later on and see how it's implemented there, but let's keep it like this for now. Let's start up the game again here. And now the stars should actually be sparkling. I hope so, at least. Doesn't look like they are. Oh, it doesn't look like they're sparkling. Maybe there's something wrong with our animation. Let me put a breakpoint here so I can debug this. Start up the game. There we go. Let me look at the animation that's been created here. It does have 4 frames. This looks fine. This also looks fine. Oh, yeah, right. It is fine. We just need to call the play method of the animation, of course. And we can do that right here in the constructor. That is fine. There we go. Now let me remove the breakpoint and go back into the game. And now it should actually play its sparkle animation. Yes, it does. All right, I'm actually happy with how the stars look, and I think the animation speed of 0.4 seconds per frame is actually quite all right as well. We could make it 0.5 maybe, but let's keep it like this for now. I think it looks okay. Yeah, let's take another quick look at it. But I think we're good. I think the speed at which they move is fine. Sparkling animation is fine. Maybe the animation could be a tad bit slower, but yeah, it's all right. Okay, so I guess we can take care of the moon now, the moon in the background. And for that, I guess we need to take a look at the original game first, because I'm not quite sure what the logic behind the moon and the behavior is, because if you take a look at the texture here at the sprite sheet, there are different types of moon sprites, and I'm not really sure when how the game determines what sprite to use here for rendering the moon. So maybe we should analyze that first. Let me start up the game. All right, so I took some time to analyze and sort of make sense of the pattern behind how the game determines which sprite to use for rendering the moon. And it appears to me that what's going on here is that in the first night it uses this sprite right here, so the second from the right, and then it just sort of shifts to the left. So the second night it will use this sprite here, then the third night it will use this full moon, and so on and so forth. And then it just sort of flips over as soon as it reaches the leftmost sprite here. Yeah, so I figured that's what we're going to do as well. And obviously we haven't implemented an actual day-night cycle yet, but I guess we don't have to yet. We will eventually, obviously. And obviously the moon as well as the stars should only be rendered at nighttime. But for now we don't care about that. Let's just implement the moon now without considering day-night cycle stuff, and then add that logic later. So yeah, there's obviously 7 different sprites that the moon can use. The first one is right here. And all of them are of the same width and height, which would be 20 and 40, except for the full moon sprite, which is yeah, double the width, basically. No, not basically, it's actually 40 pixels wide and 40 pixels high, so yeah. Let's see. So this would be the coordinates of the rightmost moon sprite. 624 and 2. And width is, like I said, 20 and height is 40. So let's go ahead and go into Visual Studio and let us create a new class. And we're going to name it Moon. I think we actually named it Moon. Yeah, we did. Okay. It's going to be public, and it's going to be a subclass of SkyObject. And of course, we need to properly implement that abstract class. And again, we can do that simply by using the IntelliSense like this. And there we go. And I guess I would have to take a look at the original game again, but I think that the moon moves faster than the stars, but slower than the clouds. Not 100% sure, I'd have to look. No, actually the moon moves... The moon seems to be moving even slower than the stars. So that's good to know. Let's go back here and let's see how we implemented the speed property in the star class. It's the T-Rex's speed multiplied by 0.2. So I guess for the moon we could go with 0.1, I guess. And we can use the protected field T-Rex for that again, of course, and multiply it by 0.1. And we also need to add a constructor, generate constructor. There we go. I will move it down a little bit there. And now let's see. Oh, okay. I mean, a way for us to not concretely implement the day-night cycle yet, but still be able to use it in some way, would be to simply define an interface that provides all of the members that we need, and then use that interface instead of a concrete implementation. So let's go ahead, and I'm just going to add it up here. Whoops. There, public interface. Let's call it day-night cycle. Whoops, there. And let's think about this for a second. What information do we need, and what does the day-night cycle, what kind of members do we need to define here? First of all, I guess maybe an integer property that tells us how many nights there have been in the game since the start of the game, so that we can determine which sprite to use. What else? Is that it? Oh no. Simply a Boolean property that tells us whether or not it's nighttime. I think that'll do. Okay. Yeah, I guess that'll do. So for now, let's leave it like that. And we're going to need to add a parameter here to the constructor, and it'll be of type I day-night cycle. I'm going to call it day-night cycle. And then we're going to add a field here, private. Let's make it read-only. I day-night cycle, and let's also call it day-night cycle. And then here in the constructor, obviously we need to initialize that field. Whoops. Like this. And now we can use this object that implements the I day-night cycle interface in order to determine how many nights have already passed in the game and whether or not it's currently nighttime. So that'll be useful. And yeah, let's see. We don't need to override the update method, right? Or do we? No, I guess not. I guess not. Okay. Let's define a few constants for the texture coordinates and stuff. So here, as I said, 625 and 2 are the coordinates of the first sprite. Actually, it's the second one, but in the cycle it's the second one, but it's the rightmost sprite. So private constant integer, maybe let's say rightmost sprite chords x 624 and y would be 2, and sprite width is 20, or was it? I think yes. And sprite height is 40, except for the sprite in the center, the full moon. We will have to multiply the width by 2, obviously, but yeah, we don't need a constant for that. Now, let's see. Basically, I guess what we could say is the draw method. Oh, of course, we need a reference to the texture, to the sprite sheet. So let's add another argument here to the constructor of type texture2. Texture2D, sorry. Let's call it sprite sheet. And then we need to create the sprites. And I guess we can just use one sprite and then manipulate that sprite. I guess it makes sense. Let's just use one sprite here. Let's say private, private sprite, and make sure to use the one from our namespace, T-Rex Runner Graphics. Let's just call it sprite. And then maybe we should introduce a new private helper method. Let's say private sprite. Or maybe, actually, does that make sense? Yeah, I guess it does. No, actually, let's just go here and say sprite equals new sprite, pass the sprite sheet, and here we're simply going to pass the coordinates of the rightmost one, the rightmost sprite. But then here, what we're going to do, let's create a method called update sprite, and this will encapsulate the logic for determining what sprite here in this sprite sheet to actually use. So let's see. Let's say, So we have 7 different sprites. So I guess what we can do, first of all, let's go up here and define a constant. It says named sprite count, and it defines the number of sprites there are. Like that. What's wrong here? Did I actually? No. Why am I using this namespace? I don't know why this using directive here has been added. Let's remove it because it creates some ambiguities here. I don't know what just happened, but never mind. So we don't use that namespace actually. So yeah. Now let's see.